Welcome to Algebra, Chapter 7, Section 3. Take a look at this. In problem 1, circle the commutative property of addition example. And number 2, circle the example of commutative property of multiplication. Let's see how you did. Here's your addition, and here's your multiplication. Remember, commutative property, CO, means you can change the order of what's going on. Our vocabulary for this video is simplify. You simplify an expression to make it less complex. Let's use our vocabulary. Let's draw a line from each expression in column A to its simplified version in column B. We are looking at exponents that have the same base. Since they have the same base, we simply add the exponents. So this becomes x, 3 plus a negative 5. Well, 3 minus 5 is negative 2. X to the 6 times x to the 1 is x to the 6 plus 1. That's x to the 7. X to the 1/4 plus x to the 1/4, when you add those together, become 1/2. Looking at 4, 5, and 6, the first step in blank the expression is to subtract within parentheses. The first step in simplifying. Problem number 5. The blank form of the expression, 17 minus 14, h, times 6, h to the 5th, is 18, h to the 6th, the simplified. And for number 6, to simplify the expression means to replace it with 12z to the 8th. So what is the simplified version of the expression p to the half raised to 1/4? Well, to simplify p to the half raised to 1/4, you must multiply the exponents because you have a power raised to a power. So we multiply 1/2 times 1/4, we get 1/8. So p to the 1/2 raised to 1/4 is p to the 1/8. In our last video, we talked about multiplying bases. And if the bases are alike, we add the exponents. In this video, we're going to talk about raising a power to a power. When raising a power to a power, you multiply the exponents. Let's take a look at number 7. In this case, we have 4 squared, and it's being multiplied 3 times. So it's 4 squared times 4 squared times 4 squared. Well, thinking back to the last video, that was 4 to the 2 plus 2 plus 2, which equals 4 to the 6. Now that could have been gotten a lot easier if we used multiplication and multiplied our power to a power. Look at problem 8. 5 to the 4th is being multiplied 2 times. So instead of writing 5 to the 4th times 5 to the 4th, we're going to do 5 to the 4th times 2, which is 5 to the 8th. W to the 5th could be written W to the 5th times W to the 5th, which of course is W to the 10th because you're going to add these. Or you can write it 5th times 2, which also equals W to the 10th. So the answer is W to the 10th. M to the 3rd is M to the 3rd. Again, I can write that 5 times, or I can just multiply it by 5 and get M to the 5/3. We're going to look at this expression, and we're going to solve it here. Our first step is to multiply the exponents of the power raised to a power. So I'm going to multiply 6 times negative 4 and get negative 24. Now, my bases are the same, so I'm going to add the exponents. So that's going to be x to the negative 22. Now I need to simplify the answer so it has all positive exponents. Well, that negative simply means reciprocal. So I'm going to put 1 over x into the 22nd power. Let's look at the other one. This is the second equation. Let's do it here. Again, first, I'm going to look at the exponents where a power is raised to a power. So negative 5 times negative 1/2 is a positive 5/2. Now my bases are the same, so I'm going to add the exponents. So I'm going to add 5/2 plus 3/2 and get 8/2. And then I'm going to simplify that so it becomes a 4. So my answer is s to the 4th. If you don't understand this, make sure you're asking class tomorrow. Here we have a cubed raised to the 6th power. So we have a to the 3 times 6, which is a to the 18th. Here we have x cubed raised to the y, so x to the 3 times y, which is x to the 3y. Let's do a couple of these together. This is x to the 4th times x to the 4th. This too means multiply everything inside the parentheses twice. When we add 4 plus 4, we get x to the 8th. Now we would have gotten the same value if we had multiplied 4 times 2. We have y squared raised to the 5th power. So I could have written y squared 5 times. Y squared times y squared times y squared times y squared times y squared. Or I could just multiply the 2 times the 5 and realize this equals y to the 10th. Here we have an interesting problem. Anything raised to the 0 power is 1, so we know this answer is 1. If we had followed our rules, our guidelines, and did x to the 3 times 0, we would have got x to the 0, which again is 1. When raising a product to a power, you need to apply the power to each part of the product inside, each factor. So each of these exponents is raised to this outer exponent. It's kind of like using the distributive property. To raise a power to a power, raise each factor to the power and multiply. So if we have AB inside parentheses, this n is applied to each of them. So it's a to the n, b to the n. So we raise this product to the 4th power. We need to raise everything inside to the 4th power. So this becomes x to the 4th, y, power raised to a power we multiply, so it's y to the 8th. This product raised to the exponent of 2, we raise everything inside to it. So 5 to the 2 to the 2, which, as you know, is 5 to the 4th. Then a to the 3 to the 2nd, multiplying is a to the 6th.